Hello students, today we are going to learn something more about the member functions of a class, and this equally applies to the member functions of the structure in C++. As we know that classes in C++ support data encapsulation, that is, the class definition can hold both function definitions and data members in them. The two are called as the members of a class, that is the function members and the data members. So far as data members are concerned, they are also called as attributes or properties or data structure. And so far as functions are concerned, they are also called as methods of a class. Now, the member functions are those functions which are present in the class definition, that is within the body of a class. All the functions other than these functions, whether they belong to other classes or whether they are independent functions, are called as non-member functions. So member functions of a particular class are those functions that are defined within the body of the class or are members of that class. Now, it is not necessary that we'll define the member functions within the class also. There is an alternative method provided by C++ that allows us to define the member functions outside the class. Okay, but for that we have to declare the prototype of that member function within the class. How we'll do that, we'll show you practically in the IDE. Now, the members defined outside the class need not to be bound to the class. The members defined outside the class body need to be bound to the class to which they belong. How this is done? This is done with the help of a scope resolution operator. This acts as an identity label to inform the compiler that a particular function belongs to the particular class. Okay. Now let us first go into the IDE and then we can proceed with this slide. Okay. Now let me define a class, say class X. Suppose I have got one data number integer a in the class X. So this, and I have got one function, say function b in the class. Now I have defined this function. Suppose it returns an integer and it finds the sum of two numbers. Then so I am defining this function within the class. Of course, I have to close the class and write a terminating symbol. Okay. Now, as you have seen, this class has got two members now. One is the integer a and another is a function num b. Both of them are taken as private. Why? Because all the members of the class by default are private unless and until we provide a access specifier to change that default access. Okay, I can make these both members as public by providing the public access specifier. Okay, now let me have one more function inside the class that subtracts the two numbers. Okay, I write that. I copy this function, I change this to function subtract. Okay, first one I can change to subtract, that is add. So I have got function add and function subtract in this. Now one does the addition of the two numbers and another does the subtraction of the two numbers. Okay, now is it possible that I can define the function sub outside the class instead of within the class? Yes, it is possible. How we do it? We write the same definition as it is. Outside the class, same statements, no difference except one difference that I'll tell you right now. Okay, now I have written the same definition outside the class. If you have to write the member or implement the member function of a particular class outside the class, you have to write the definition of that member function outside the class. Then another thing you have to do is you have to write the prototype of that function within the class to inform the compiler that you will be implementing some function whose of a class, that is some member function of a class outside the class, whose return type, function name and formal arguments will be of this type. If you see this function, what has been written outside the class now, there is no way that it is bound to the class. It can be simply treated as a non-member function. The only way how we bind this function to the class is we use the scope resolution operator and the name of a class as a prefix to this function name. So we write x and a scope resolution operator because the name of the class is x, and we have written a scope resolution operator to inform the compiler that this function belongs to the class x. If we don't do it, then it will be considered as a non-member function. Yes, because we can have same function within the class with exactly same definition as a non-member function. Let me show you how. Suppose I have got this function. Now this function, I copy this function here and I paste it outside the class. Now I have got two functions, that is function add within the class, and I have got another function add outside the class. Let us see if compiler generates an error in this case. So there is no error. Yes, we can have the function with exactly same name, same arguments and same body outside the class also, but this function add is not a member function of a class. Okay, why? Because it is not bound to the class with the scope resolution operator, and its prototype has not been declared within the class. Now if we compile it, let us see what happens. So compilation is a success. Now we can even call this function add independently of a class, but we cannot call the function subtraction independently of a class, that is independently of a object and a dot operator. Why? Because this is a member function, and in order to call a member function one has to use a dot operator. Okay, let me show you how I can call function add without a dot operator. This clearly tells that this is a non-member function. Okay, I have to give parameters because I have given 2 parameters. Now see, this call is made to the function. This was simply to show you that we can have another function which is a non-member function, but that has got the name exactly as the member function, arguments exactly as a member function, and body even exactly as the member function, but it is not a member of a class. Why? Because it has been defined outside and it has not been bound to the class by a scope resolution operator. If I have got another function, suppose I define it outside, say non-member function int k, this is the example function. Okay, I'm simply writing the statements here, just trying to show you some programming exercises that might help you in understanding it. Now I can say L is equal to L plus 1. Okay, now this function is exactly a non-member function up to this stage because it does not lie within the class, it is not defined within the class. And second thing is that if it is defined outside the class, it is not bound to the class with a scope resolution operator, or it does not have the prototype inside the class. Okay, let me compile. So I have got 2 functions within the class X. One is a function add, one is a function sub. But function add I have defined within the class, and function sub I have defined outside the class. Now this is the definition of the function which I have defined outside the class. Okay, now can I make a non-member function, suppose k, as a member function of class X? Yes, I can. How? First I declare the prototype within the class, that is the first line. Since it does not have arguments, so I need not to specify the data type of the arguments in the prototype, and then bind that function to the class by using class name and scope resolution operator. Now if I compile it, this member k is now the member of a class. So non-member function defined in the program can be made as a member function of a class. How? By simply declaring its prototype within the class and by prefixing the function name with the scope resolution operator and the class name. This is how we bind a function that has been defined outside the class to a particular class. In this exercise we have seen how we can define a non-member function outside the class. Okay, now is it clear? Let us go back to the slides and see what the member function declared outside the class body are treated as outline. Yes, this is another important thing. Once we define the member function within the body of the class, these functions are taken as inline functions by default, provided they don't have looping structures inside them. In that case, the compiler will inform us that the particular function has not been expanded inline. In case the compiler informs that, then you must know that this function has been treated as outline function, and it will have function call and return mechanism and the other features that are linked with the outline or non-inline functions. This we have also discussed in a video on inline functions. Now two different classes can have similar member functions. Let us see that also. We can have a member function of a class, and the same function, the same definition can exist outside the class, but it will not belong to that class. Like we have shown function add. The same function add is present as a member of a class, and the same function add is present as a non-member function. Okay, now we'll show you how we can place the same function in another class, also same function definition. Okay, I will create a class y. Now I enclose function add in that class. Okay, now I have got function add now present at three places. One is within the class X, okay, one is within the class Y, okay, one is it is not a member of any class. Okay, so three possibilities. I can have a function as a member function of one class, and same function with the same definition can be the member function of another class, and same function can be a non-member function which does not belong to any class. Okay, but these three functions are treated as three different functions because we cannot call a member function of a class without using the dot operator and the object name. So once we qualify a function name with the dot operator and object name, then only we can call a particular function. In that case, the name of the function becomes object name dot function name. Okay. In the case of class Y, again we will be calling the function with the object name dot what you call function name. But since class X, the object of the class X is different from the object of class Y, because object of the class X has the data type X and object of the class Y has data type Y. So the function add of class X will be treated as totally different function from the function add of class Y, because first one has been qualified with the object that has a data type X, or called with the object that has the data type X, and second one is called with the object that has a data type Y. Now this function, that is another function that is a non-member function and does not belong to any of the classes, can be called independently of the objects, and therefore these three functions will be treated as three different functions. But the point here is that we can have the same function with same body, same arguments and same return type within the class, or within another class, or with as a non-member function which does not belong to any of the classes. These are the three possibilities. That is what I am saying here. Two different classes can have similar member functions. Okay, the member function can access all members. Now this is an important point. By accessing all the members means the member function can access both public members, private members and the protected members. Now members can be both data and functions. Let us see this. Okay. Now let me define a class example. Right. Class example. I declare int public pub a, okay, as a public member, and another one I declare with as a private member, another data item I declare as a protected member. Now I can have member function of this class as suppose int, which I will define this within the class. Okay, a, suppose function a. Let us see whether it can access the three members, that is pub a equal to 10, I'm accessing pub a, and pry a equal to 10. Okay, and pro a equal to 10. Accessing means inputting a value, outputting a member, or inputting a member, outputting a member, or displaying a data member. That is what is meant by accessing. Inputting a member, outputting a member, or using it in a assignment statements. Okay, now let us compile and see whether there is violation, what errors it is showing. I have to use the terminator here. Okay, there is no error, so this access is allowed. Now I define another member function outside the class. Suppose int b. Let me define the function first. Okay, and access all the three variables there, three members there, access all the three members there. Okay, now this function is not still a member function. Now I have to make it as a member function. How? I first declare the prototype of this function within the class. I can even begin with the prototype first, that I will first write the prototype within the class, then I will define the function. So both ways it will be okay. Okay, now I bind this function to the class by using the class name. What is my class name? Class name is example, so I will write here now example, then scope resolution operator. That is the b belongs to example. Okay, class example. Now let us compile it. This shows that whether a member function is defined outside the class or within the class, it can access both public, private and protected data, and even it can access all the functions, whether they are public, private or protected, which are the members of that class. Okay, accessing a function means calling a function. Okay, accessing a data member means performing input, output, or use it in a assignment statement, either LHS or RHS. Okay, now the member we were here. The member function can access all the members. This is what is meant by this. The member function can access all the other members of the same class, not the members of other class, but the members of the same class. That is, if we have a member function of a particular class, it can access all private, protected and public members of that class. Okay, that is, the access specifier rule does not apply to the member function. Now the member function can be defined within the class or outside the class, and this rule applies to both the member functions, that is, whether they belong whether they are defined within the class or whether they are defined outside the class. Okay, now member function can access all the members of object with which it is called without the dot operator. This is again important, we'll see it. Let me write a public member again, one more public member in this class. There's a rule that we can use access with specifier as many times as we want. Okay, now I can make this public access specifier I can use. So whatever I'll be writing of this, after this we'll have a public access specifier, whether it's a data member or a function member, that will be having no public access. By write a function k in the class, okay, which does not return anything. Now what I do is I'll say pub a equal to 9, pry a equal to 9, okay, and protected pro a equal to 7, okay. Now k is a public function member that can be called with an object. Let me create an object of this class example, say O1, O2, okay. Now I have created the two objects of the example class. If you see now, the members of object are a data member public A, a data member private A, and a protected A, and a function A which has got a protected access, therefore cannot be accessed by any non-member function using an object. And I have got a object of this class, and I have got a public member. Okay, now since I have created the objects, that is O1 and O2, now let us try to access B. O1 dot B, that is I will call B. Can I call B? Okay, let us see. There is an error. Why there is an error? Because this is the error. Function is not accessible. Why is it not accessible? Who is trying to access it? Main is trying to access it through the object of the class. Okay. Now since main is trying to access it through the object of the class, if we see B, let us see its access specifier. If you see, I have declared B here, prototype of B, and before that the access specifier is protected. See here, protected. This protected access specifier applies to the data member pro A, the function member A, and function member B, because after that we have written a public access specifier. Now even the function, if it is declared outside the class, we have to see its access specifier. Depends on where you have declared the prototype, and you have to find the access specifier at the top, and that will apply to that function. Okay, now so we cannot access the B. Okay, now if I will access another function that I have declared, that is k. K is a public function. It can be accessed with O. Okay, O. Now, who is accessing the k function actually? The function k is actually accessed by main, which is a non-member function, because this function is calling k. In fact, it has to call it with object, because k does not have any independent existence, since it's a member of a class. Members of the class don't have an independent existence. They are to be either accessed with an object or with a pointer or with a reference of that class. Okay, it's a non-member function. But once it's a member function, we don't need a dot operator to access a data member within a member function. Okay, let us try to see that how that works. So see here, I am calling the function k with O1. Let me watch it. If you see object O1 has got 3 data members, what are the 3 members? That is public A, private A, and protected A. These are the 3 data members. The rest of the other members are functions. Now what I am trying to do with this, I am calling the member function k with the object. Okay, I'm not calling it, it is main who is calling. Okay, if you see, I am accessing pub a, pry a, and pro a. Now this pub a, pro a, and actually belong to the object O1. Am I using a dot operator within the member function? No, because I am calling the function with the O1. So you should take at that time, if I am referring to the data members, they are the data members of O1. Now you see pub A has been initialized to 9, pry A initialized to 9, and pro A initialized to 7. That is O1 dot pub A is equal to 9. Similarly, O1 dot pry is equal to 9, and O1 dot pro A is equal to 7. Let us see once we come back. See here, O1 has been initialized to these values. In other words, in the member function, if I refer to the data members, I am referring to the data members of that object with which I am making the call, and with which I am making the call, and I don't have to use dot operator for the data members within a member function for the object with which I am making a call. Let us now make a call with O2 for the same function. Okay, once I make a call with O2, that is object 2 with the same function, now let us watch O2 also. Okay, now once I call, you see here, let me close the message window first. Okay, you see here, now if you see first, I have not called yet. If you see here, once I make a call to k using O1, see what there O1 has a junk values. Note these values. Okay, 28745 Now let me make a call to k. I am referring to pub a, pry a, and pro a, that is the data members of the class. But I have called the function k with O1. Okay, now let us see. Once I change the values of pry a, pub a, and pro a, see the members of O1 have been initialized to these values, even though I have not used that dot operator. Now this time I am calling with O2. You see here O2 values stored in pry a, pro a, and pub a of O2. Okay, now see here, once I call it and return back, you see the O2 has also changed. Did I use the dot operator? No. What does that mean? That means whenever we make a call to a member function with the object, and if we refer to the data members of that class in the member function, then those members are the members of the object with which we have made a call, but we need not to qualify those members with the object name and dot operator. Okay, and whatever changes we make in them, or whatever accesses we make in them, we are making those changes to those data members which belong to that particular object with which we have made a call. I think it's clear now. In other words, I call it as object is the implied argument to the member function. That is, whenever you call a member function, and in the member function you access the data members, you are accessing the data members of that object, okay, with which you are making a call. Let us see this. So this was our point, that member function can access all members. This we have seen. It can accept public members, private members, and protected members. Member function can access all members of the object with which it is called without the dot operator. This we have also seen. Whenever the member function is called, it can access all the members of an object with which it is called without the dot operator. If the object is passed to a member function by reference or by value, dot operator is to be used. This is in case we pass the objects as an actual arguments and receive it in the formal arguments in a member function. In that case we have to use a dot operator. Okay, in that case, that is in case we pass objects of the same class as a arguments to the what you call a member function, and then we can access the members, both data and function members, using a dot operator. Okay, we'll see again once I'll be showing you how to pass objects to the as an arguments to the member functions. Okay, if the object is passed by address, then instead of dot operator you have to use an arrow operator, because we use arrow operator on pointers. Okay, member functions declared as public act as interface between the server and the client. Since the only way to access the only access that a class provides to the object is the public members, that is in any non-member function of a program we can access only the what you call public part of a class. Therefore the public part of a class acts as an interface between the caller and the called function. Note, the class is a server and the calling function is a client. Okay, so once we call a non-member function calls a member function, it can call only those member functions which are public. Therefore the member functions which are public serve as an interface between the class and the non-member function, that is the client. Okay, member functions can also be overloaded. This is another thing. Okay, now we can have two member functions inside the class with the same name, suppose, provided they differ in number, type or order of the arguments. Suppose I have got this member function, I can have another member function with the same name within the class. Let me declare another function. Now I have got two functions with the same name, but here they should at least differ in their formal arguments, either in their type, number or order. We have already discussed it in function overloading. So member functions can be overloaded. Now suppose I have got two member functions, that is a and a with the same name, but there is a difference in their argument types, that one has got one argument and the second does not have any argument. So this is overloading, function overloading, and once I compile it, you see there won't be any errors. So this is acceptable. Okay, so we can have two member functions with the same name within a class. Again, outside member functions can be made inline by using a inline keyword. As I told you, the inside member functions by default are inline, and those member functions which are defined outside the class are taken as outline. But the member functions which are defined outside the class can be made inline by using a keyword inline. Okay, now every class has two special member functions, that is the constructor and destructor. We will see that in the separate video lecture on member functions. Okay, now let us see what are static member functions. Okay, static member functions are those functions which can access the static data members only. We have already seen what are static data members. Static data members are those data members for which only the memory is allocated once, and all that copy is shared by all the objects of that class. Okay, so they serve as a medium for sharing of the data between the objects, and these members can be accessed even before creation of objects. That is, memory is allocated to these members even before declaring the objects of a class. This is what makes them again different from the non-static members or automatic data members of the class. So memory is allocated to static members when the program execution starts. We can access the static members without the objects by using the scope resolution operator and a class name. Okay, now we have got static member functions. Static member functions are those functions which access the static data members only. So these functions can be also called even before the creation of the objects. Okay, because the static members, that is static data members, are allocated memory even before the creation of the objects, and the static functions access only static members. Therefore these functions can be called before creation of the objects. Let us see how we create static member functions. Now let us create a class X in which I create one static data member integer a by using a prefix static. Okay, now I have to initialize the value of this member. How do I do it? I do it outside the class by using int. I don't use a static keyword here, and then prefixing the variable name with the x and the scope resolution operator to indicate that this is a variable that is bound to the class, because I can have a global variable declaration possible here, like suppose int y equal to 9. Now this is a global variable y and it does not belong to the class. If I compile it, okay, there are no errors. Now what indicates that y does not belong to the class? Because if we would not have prefixed a with a class name and a scope resolution operator, it was somewhat same like a global variable. And as I told you, the memory to the static variables is allocated at the time of what you call execution, when the program starts execution. So that way they are similar to the global variables. But what makes them different from the global variables is that they are associated with a class and they cannot be accessed independently. At least for accessing them, you can use the objects of that class, or you have to use the class name itself. Okay, now I have initialized the static variable a. Let me create a static function. Okay, I'm defining a static function, say suppose n, within the class as a member function. Okay, suppose this is n, it does not return anything, and let us access a in it. So I can say a equal to 10. Let us see if there is error. So it's a success. So I can access the static member a within a what we call a static function, because n is a static function. How is it a static function? Because I have used a static keyword before its declarator. Okay, now let us have another data which is not static, say c. Let us try to access this in the function. If I say b equal to 90, now this is a non-static or automatic data, and the copy of it will be shared by all the objects of the class X once I create the objects of this class. Let us compile it and see what there is an error. What is the error? Member b cannot be used without an objects. Okay, so the static function, as I told you, it can access only static data members. This is a rule. Now So static functions are those functions which can access only static data members, and static data members are those data members for which one copy is allocated for all the objects. We have already discussed this in a video. Now, how can I access a static member? We can access only static member functions and static data provided they are public. This is a general rule, right? We cannot access the private and protected members. Okay, suppose this is a public keyword. Okay, now let me create another static member with a private keyword. That way, say static key. Can I access key? Let me initialize the key first outside the class, that is int x of k equal to 9. Is it acceptable? Yes, it is acceptable. That even if I have a private member, I can initialize it outside the class. Now let me try to access the a first within the main. That is a non-member function. X of a equal to 19. I am accessing the x of a, that is the static member of the class a, within the non-member function, and the rule is it can access only, the main can access only, since main is a non-member function, it can access only public part, and a is a public static variable. Once I compile it, okay, it is a success. Okay, once I compile it, see here, it's a success. Okay, now let us try to access the member, another static member which I have declared. What was that? Static k. Okay, I can take it as static int k. Okay, now let us try to access k within the main. Okay, x of k equal to 90. Again, main is trying to access the k. What is the compiler message? The compiler says that x of k is not accessible. Why? It's not accessible because it's a private static member. So the private data members, whether they are static data members or static data function, they cannot be accessed. Even if they are protected, they cannot be accessed. Only public static data members and public static functions are accessible outside the class. Okay, now let us create another function here, which is a private function. Again, static type, static. Okay, int, say void, we can say. Just to explain you, this is a function kim. I am not writing a specific applications or specific programs. I am simply writing random statements, but I am trying to explain the concepts. So don't be worried if you don't understand the program, but just understand the concepts, because the concept here is what is the static data and what are the static member functions and what are the rules for access of the static data members, that is if they are static functions or if they are static data members. Okay. Now again, kim is a static function. How? Because it is preceded with the static keyword. We have now two static functions. One is the n and one is the kim. Okay, but n has the access specifier as public and kim has the access specifier as private. Okay, let us try to access kim and now here k was not accessible because it was a private member. I will say x of n. Okay, then I can say, let me compile and see if the access is allowed. Okay, n is accessible because it is a public member. So a main is a non-member function which is trying to access n. So non-member functions can access only public part. Okay, now x of kim, main is now trying to access the kim function of the class, and that is a static member function. Is that allowed? No, I don't think so. Why? Is not accessible because it is private. Okay, so non-member functions of a particular class can access only public and only access public members. Okay, so the public members provide the interface to a particular class, but it is possible to access the static data members and static functions even before the creation of the objects and without objects. How? By using a class name and by prefixing the function call with a class name and a scope resolution operator in both cases. Okay, this was all about static member functions. So in short, we can say that static member functions are those member functions which can access only static data. We try to access non-static data, that is the automatic data, within the what you call static function. This access was not allowed. Let us try one more thing. Let us have another member which is a non-static member in the public section, but it is a function, say function v. Okay, now v is a function. It's a non-static function because I have not preceded the function with that static keyword. Now, can I call this function? Can a static member function call this function? Let us see. Let the n, that is a static member, call a non-static member of the same class. Is that access allowed? Error, yes, it's not allowed. Why? Because v is a non-static member. Non-static member cannot be accessed within a what you call a static member. Okay, I hope this is clear now. So a non-static member can access only static members, that is it can access the static data or it can access the static member function, that is it can call them. This was all about static member functions. I hope you have understood today's video. Thank you.